learning goal today states, I can find and graph rates of change. So let's define first of all what a rate of change is. A rate of change is a ratio that compares the amount of change in a dependent variable. So fill that in. Dependent variable is the forerunner in the comparison. And we know what dependent variable is. Which variable typically takes on the role of being the dependent variable, the x or the y? It's dependent on the other one. Y is, yeah, y is dependent upon what you do with x. Remember, the function rule is what x is in. So x takes charge in the function rule, and y is dependent upon that. And then we compare that to the amount of change in the independent variable. So this is kind of like one time the dependent variable gets to take charge. It gets to be first in the ratio. It's always upstairs in the ratio, the y values, and the x's are downstairs in the ratio. So let's go to page 244 in your books. I have probably written a lot of information that we need for this, but let's go see what other information we need to glean from this page. Page 244. We are doing the check it out problem number 1 at the very bottom of the page. So it does appear that I have copied the table for us. But what I did not copy down was what is this table representing, okay? So who wants to read that for us? What the table, what this is about? Volunteer. Go. You don't know where I'm at? Bottom of page 244, number 1, check it out. Okay, Preston, thank you very much.
The table shows the balance of a bank account on different days of the month. Find the rate of change for each time interval, during which time interval did the balance decrease at the previous rate.
Okay, thank you, Preston. So, you know what's really important in there, that middle sentence? Find the rate of change for each time interval. Okay? So when we talk about time intervals, here's what we're talking about. It starts at day 1, and the next day in the table is what? Day what? 6. So from day 1 to day 6 is a time interval in this problem. What's the next day in our table, Holly? Day 16. So the next time interval is from day 6 to day 16. And what's the next day in our table, Seth? 22. So our third time interval is from day 16 to day 22. And there's one more interval. It goes from what to what? Sydney? What does it go from? 22 to 30. From day 22 to day 30. So we have 4 time intervals here for which we're going to have to find 4 rates of change. And I'm making a big deal out of that because I don't want you only to find one and think that you are done, okay? So we are going to, first of all, what we're going to do is we're going to plot each of these points and connect them with line segments to show those intervals, okay? So go ahead and, first of all, we're going to decide what are we're going to finish numbering our x-axis. What's it going by?
2's.
2's. But I only started labeling that every other one, right? So go ahead and finish numbering these, and some of you have got to spend more time being careful about this. So if you're going to skip every other grid line like I started it, when you're done, you should be able to just keep adding 4 and numbering. So 8, skip a grid line 12, skip a grid line 16, and you should end at 40. What's the y-axis going by?
50's.
50's. Careful. So notice how I did this little zigzag in the graph here? Some of you need to learn how to do that also. If you're going to, okay, it's going by 25. So I want to start at 150. The next grid line would be 175. that I've labeled is 200, so I'm not really going by 50s, I'm numbering every 50. So we're going to jump over grid lines again, and we're going to finish labeling our y-axis. If you want to do every $25, you can. And this one should end at $600 at the top. Okay, so it looks like I've already chosen for us what the independent variable is and what the dependent variable is. I'm saying that the days, which day it is, controls how much money is in that account. It's the independent variable. So the days are the x's in this, and the balance are the y's. So that's going to be kind of important for us to plot the points and when we find the rates of change. So we actually have here 1, 2, 3, 4, 5 ordered pairs to put on our graph, and when we connect them with line segments, it should show our 4 time intervals that we talked about. So go ahead and put ordered pair 1, 550, plot that point on your graph. Where would that be? Well, the 1 would be halfway between the start and the first grid line. And make a good judgment call where your points should be. Okay, don't just be, it's kind of like doing our scatter plots. Don't be just random about it. Okay. Once you have your 5 points in the graph, starting with the first point, draw a line segment connecting the first point to the second point. That will show the first time interval. So a line segment connecting that first point that you put on there to the second point. I'm going to undo mine, do it a little bit better. So there's my first line segment. My first time interval is being represented with that. I'm going to take my ruler and turn it, so I'm going to be able to connect the second point to the third, showing the second time interval. Third to the fourth, showing that time interval, and fourth to the fifth, showing that time interval. So we should have 4 line segments, 4 time intervals represented on our graph. Okay, just taking a look at our graph, let's just use our graph to answer the question, which time interval from which day to which day did it appear that the bank balance decreased at the greatest rate? Decreased at the greatest rate, because it appears it's going down pretty much all the time, right? So, in which time interval, which of those 4 line segments would you say the balance is decreasing at the greatest rate? Adam?
Day 1 to day 6.
Okay, from day 1 to day 6. So you're talking about this one right here, right?
Yeah.
Okay, do you guys agree with it? Does it appear right now that on the graph that one would be? Why did you choose that one, Adam?
Because you went down 300, but maybe 400, maybe 300, something.
I don't even want any numbers involved. How about?
Because it decreased at a.
Go ahead, Seth.
It goes down the fastest and shorter in 1 days.
It goes down the fastest. It's the steepest, isn't it? It's kind of like falling down the fastest there. So it appears right now, we would say from day 1 to day 6, as Adam said. So let's check it out now by we're going to actually find those rates of change, and then we're going to put them on the graph also to show what they actually are. So day 1 to day 6. Remember how we find rate of change is the says find the change in the dependent variable. So we're going from day 1 to day 6, okay, right here. Oops, I didn't need a pen. So go to our table. We need the y values. The y values are the days or the balance. Which one? Change in the dependence upstairs. Which one's the y values are the balance. So we're going to take the balance on day 1. What was the balance on day 1? $550. And we're going to subtract the balance on day 6. How much was it on day 6? $285. Yeah, I'm trusting you guys. I'm not looking at my table, so give me good information. Days downstairs. Day 1, take away day 6. This is where your calculator will come in handy. 550, take away 285. How much? 265. Thank you, Holly. 1, take away 6. -5. -5. And we need to make, account for positives and negatives in this. Because now you're going to do a division problem. But before you do it, you're going to at least do this much for me. A positive divided by a negative is a negative. So we know we're going to end up with a negative rate of change. And now what is 265 divided by 5? Negative 53. Okay. Now, that is negative 53. Remember, this is dollars upstairs. Dollars. And downstairs, when we divide, we're getting it per 1 day. So it's going down at an average rate of $53 a day. Did it maybe actually do that? No, but we're showing what happened over the time interval. So let's go to our graph and let's put that on there. This one is a negative $53 per day. That's a pretty good decrease every day, so maybe we were right. So we're going and identify it on our graph also. Okay, day 6 to day 16. What was the balance on day 6? 285, what we left off with in the last one. What was the balance on day 16? 210, okay. Downstairs, 6, take away 16. Order matters in subtraction. So if we start with day 6's balance upstairs, we have to start with day 6 downstairs. 285, take away 210. 75. 6, take away 16. Negative 10. Positive divided by a negative. A negative. 75 divided by 10. 7.5. Okay. Now, we know that is dollars. So since it's dollars, what are we going to put behind that 5? $7.50 per day, per 1 day. Okay? So already, you can see that first interval has a greater decrease than this one. So let's go to our graph now and let's put this one, I think I'll just write it down here just so I don't have them on top of each other, a negative $7.50 per day. It's decreasing at an average rate of $7.50 a day. Okay, so we've got 2 time intervals covered. Each of them have their own rate of change. Notice every single time, this is important, I'm not letting you off the hook here. This is important. Every time rates of change have a label. Actually, 2 labels. This one is dollars per day. How many dollars per day? Okay, day 16 to day 22. Who's got the setup for us? How's this one going to go? Upstairs.
210 minus
210, take away 210. The balance on day 16, take away the balance on day 22. What's going downstairs? Talia? $16, take away 22, okay? 210, take away 210. 0. 16, take away 22. Negative 6. 0 divided by negative 6. 0. 0 divided by anything except itself. It can't be divided by itself. 0 divided by anything is 0. So this is $0 per day. $0 per day. So now we'll go up to our graph. You guys will go up to your graph too, I guess. And you'll say this one is $0 per day. Now, so far, are all the rates of change we got making sense when you look at the picture and look at the graph? The first one was quite large. It was negative. It was going down a fair amount every day. The next one, it didn't go down near as much every day. And notice the difference between the steepness and the line segments. Tell me why we should have expected this one to come out $0 per day. Why should we have expected that by looking at the graph? Okay, you guys are working ahead of me. Why? I'm asking you a question. I want you to answer right now. Okay, well then stay with me. Why should we expect by looking at the graph at that third line segment, why should we expect that that makes sense? It would be $0 per day. Thank you, Seth. Yeah, it's even. It's a horizontal line. Remember, horizontal lines on graphs we said mean no change, right? No change. So we should have expected that the balance would not change in this one. Okay, now go ahead, work ahead and get the last one for me. Does this one come out to a nice, like, what looks like money number? What does it come out to? Negative 4.375. And that would be per one day. Each day, that's how much it went down. 0.375, what is that really in money? Even though we know we can't be like this, what would 0.375 mean? It'd be, 37 and half of another cent. 37 and a half of another cent. So if it's really not going down exactly $4.37 every day. It's not going down $4.38 every day. It's going down an average of $4.37 and a half cents per day, even though we know we can't deal in pennies. Okay, so now let's go put that one on our graph. We have a negative 4, and we could just leave it 4.375. It's okay. And now let's see. Did we answer our question right? The balance decreased at the greatest rate from day 1 to day 6. True or false? True. Yeah. The greatest negative value we got was that first interval, the negative $53 per day. So, first of all, I just need to point out some things that are really important when you're doing rates of change. You've got to decide what's going to be the independent variable and what's going to be the dependent. Because if you don't decide that, you're going to put the wrong thing upstairs, which will then lead you to putting the wrong thing downstairs. What goes up? The x's or the y's? The dependent or the independent? What goes up? The y's do, the dependent. Downstairs in your ratio is the subtraction of the independent, the x's. So you've got to make that decision. They're not always going to do that for you. Another important thing is if you have, you should be able to see that you have intervals here. Here's 1 interval, 2 interval, 3 intervals, 4 intervals. That's why we got 4 line segments on our graph, 4 different rates of change. So really important that we make sure that we have those intervals graphed, show them, and then we give what rate of change each of them shows with labels. Okay?
Please dismiss all students participating in the production of Zombie Night at this time. Thank you.
Okay, anybody have any questions on this one before we move on to, I think there's one board practices or not, in the back? Okay, let's go back to the The table shows the average temperature in degrees Fahrenheit for 5 months in a certain city. We don't know where this is. Find the rate of change in temperature for each time period. During which time period did the temperature increase at the greatest rate? Okay, so it we can kind of see as we look across this table, the temperature is increasing. So let's first of all do what? What would be our first move here? What do we do first in the last problem? Do we find rates of change first, or do we graph first? You don't even remember anymore? 10 minutes ago? Come on, folks. Did we graph first or do rates of change? We graph first. Okay, so we have how many ordered pairs, how many points to put on this graph? 5. Okay, so let's go look here. Somebody helped you out and set up the thing for you again. I say that the months are going to be the X's. I say that the temperature is going to be the Y's. Let's see if that makes sense. Does it make more sense to say how much the temperature changed every month? Or does it make more sense to say how much the months changed for 1 degree temperature? It makes much more sense to talk about temperatures per month. So let's finish labeling our graph first of all. Since I've already started it for you, you can finish it. Again, there's a break in the graph on the y-axis, so I show that little squiggly saying I want to start at 50. What's the scale on the y-axis? What's it going by? Twos, yeah. Okay, after you have it numbered carefully, you are not doing a very good job with this, make sure you do. Then go ahead and plot your 5 points. Time intervals are we going to have? No. 4. We start with our first point, and we connect the first point to the second point. There's 1 time interval. We connect the second point to the third. There's our second time interval. Third to the fourth. There's our third. Fourth to the fifth. There's our fourth time interval. There should be 4 time intervals, 4 line segments on your graph. And the question, I wrote it here already for us to fill in, but do you think we're ready to do that? Tell when the temperature increased at the greatest rate? Can you tell? It kind of looks like it could be between the second interval and the third. They're kind of like running a close race, aren't they? So I'm not sure we probably want to do that till we actually find them. So how about we find them first, okay? So rates of change, months 2 to 3. You can always identify what interval you're working on. Do what I did here. In your homework, write it down. Month 2 to 3, okay? Because then it also makes it really easy for your downstairs. You can just look at it and you can say, oh, the time is 2 take away 3. We're not going to answer that quite yet because we looked at the graph and we said it's kind of hard to tell. So we're going to do the calculations first. So what was the temperature in month 2? 56. What was it in month 3? 56. So we got 56 take away 56 upstairs. Temperature change upstairs. Month change downstairs. I end up with 0 over -1. How about you? Okay, what is that? 0. Okay, label. 0 degrees Fahrenheit per day. Really? Per day? For what? Per month, yeah, per month. I just took your word for it there, Seth. Okay, so now we're finding the temperature change per 1 month, the average change over a month's time. So this one was 0 degrees Fahrenheit per month, which should make sense because it's a horizontal line segment. Okay, go ahead and try and work the next 3 on your own. I'm going to do it up here. You can use me as your rescue if you need to, but otherwise I want you actually working it on your own. After you have your 4 rates of change, you want to verify that you agree with me, then what do we do with it next? We put them on the graph. So go ahead and put them nicely on your graph showing what each interval, each line segment, rate of change is. Okay, so all of us should have gotten, we all did get 0 degrees Fahrenheit change for the first time interval. The second time interval, the average change was 3.5 degrees Fahrenheit per month. The third time interval, it's 4 degrees Fahrenheit per month. And our last one, 1 degree Fahrenheit per month. Do you agree with me? Okay, now can we see why it was hard to tell from the graph? Which one had the greatest increase? Which time interval had the greatest increase?
4 degrees Fahrenheit per month.
From month 5, so the 4 degree one, so from months 5 to month 7. Okay, so from month 5 to month 7. They're only half a degree apart. That's why it was kind of hard to tell from our graph. So the rates of change helped us be able to find it without just having to guess. Okay? So, anybody have any questions? Okay, you're going to need loose leaf paper for the homework to do all this extra stuff on that we were just doing. And I have a graph handout for you to do the graphing part, and everything that we did on the graph would be done on the graph hand.